Hello friends, this is Priyanka. Today we are going to solve a problem on economizer from the chapter Boiler Accessories. Let us first understand why this economizer is used. Feed water from the boiler is getting heated by using the heat from the flue gases, and 1% of fuel cost is getting saved for every 6 degrees Celsius rise in the temperature of boiler feed water. So what is the purpose of economizer? To save the fuel cost. Now I will read what is the given problem. An economizer is to be designed to heat the feed water at 170 degrees Celsius and 140 bar till it becomes saturated water at that pressure. The flow rate of feed water in the economizer is 600 kg per second. The heating of feed water is carried using hot gases which are flowing at the rate of 1250 kg per second and comes out at 450 degrees Celsius. The gas velocity is limited to 12 meter per second to avoid excessive erosion. The optimum velocity of water is 1.2 meter per second. The tubes used have 70 mm outer diameter and 60 mm inner diameter. Take overall heat transfer coefficient UO, that is equal to 80 watt per meter square degree Celsius. Specific heat of the hot gases, that is CPG, is equal to 1.12 kilojoule per kilogram degree Celsius. If the vertical pitch of coil is 8 cm, clearance to each side is 5 mm and duct width is 4.8 meter. Find the vertical height of the economizer coils. Take LMTD cross, that is log mean temperature difference cross, is equal to log mean temperature difference counter multiplied by 1.12. So this was the given question. Let us first understand the given data with the help of diagram. Inlet feed water. So what is the condition for inlet feed water is given, that is temperature 170 degrees Celsius and pressure is 140 bar. If we observe the diagram for economizer, here is the feed water inlet and through the tubes feed water is moving, and here is the feed water outlet and flue gas is passing through this vertical section. Now we will write here the inlet feed water condition. So for this feed water inlet we will write here 170 degrees Celsius and 140 bar. So these are the conditions for the inlet feed water. Now outlet feed water. So for outlet feed water it is given that pressure remains same. So for this outlet feed water pressure is 140 bar only and it becomes saturated. So this is also the condition. So we will write here as a saturated water. Then mass flow rate of water is given. So mass flow rate of water, that is when water is moving inside these coils, then mass flow rate is given 600 kg per second. So we will use here the notation m to the base w. Then mass flow rate of the flue gas is also given. Whenever this flue gas is moving, then it is 1250 kg per second. Then outlet flue gas. So here outlet flue gas, here is the flue gas is entering and here is the flue gas, that is outlet is given. Here temperature is 450 degrees Celsius. So I will mention here the temperature 450 degrees Celsius. Then the velocity of flue gas is given 12 meter per second. Velocity of water is also given 1.2 meter per second. Then outer diameter and inner diameter of the tubes is also given. So water is moving inside these tubes. So what is the outer diameter? 70 mm and inner diameter 60 mm. Then overall heat transfer coefficient. So overall heat transfer coefficient U to the base O 80 watt per meter square degree Celsius. Then specific heat of the gases. So here specific heat of flue gas is given. So notation is CPG. So for flue gas we will use suffix G, and for water we will use suffix W. So specific heat is given 1.12 kilojoule per kilogram degree Celsius. So I will mention here CPG is equal to 1.12 kilojoule per kilogram degree Celsius because it is given. Then the vertical pitch 8 centimeter. So I will use here the notation that is small p. Vertical pitch 8 centimeter. Clearance 5 millimeter. So clearance is also given. So I will use here the notation C. So what is the clearance? So in between these two vertical sections, here is the some space is there in between these tubes and this vertical section, and this is known as clearance. So we have to mention this clearance. So I will mention here. So this clearance is given. So I will write here as a notation C, and it is given 5 millimeter. Then duct width is also given. So for this duct width 4.8 meter. So I will use here the notation B. And what is this duct width? So this is the duct and this is the total width. So I will mention this is as a B, and it is given 4.8 meter, and this is the clearance, that is 5 millimeter. Then condition is given, that is LMTD cross, that is log mean temperature difference of this cross sectional moving, which is equal to LMTD counter multiplied by 1.12. So why this condition is given? Because whenever we are going to calculate log mean temperature difference, then that log mean temperature difference is the value for LMTD counter, and this is the correction factor. So for this given setting, if we have to find out actual log mean temperature difference, then we have to multiply with this correction factor 1.12. So we have to use this. So here may be LMTD actual or LMTD cross, but whenever we apply the formula, then the answer for log mean temperature difference is for LMTD counter. So this correction factor is given, so we have to find out the actual LMTD. And when all this data is given, then what we have to find out? So we have to find out vertical height h. And what is the formula for the vertical height h? That is n multiplied by p. So this, what is this n? N, that is the number of turns. So we have to first find out the number of turns, and here pitch is given. If we multiply this number of turns and this pitch, then we will get here the vertical height. Now we will understand the formula. Here it is given that heat transfer between the flue gas and feed water is given by. So we have to first analyze what is the given formula. That is, let heat transfer Q is equal to MW, that is the mass flow rate of feed water, CPW, that is the specific heat of water, and the temperature difference. So here temperature difference is given, that is the temperature of feed water outlet minus temperature of feed water inlet. Because whenever the heat absorption is taking place by the feed water, then this feed water at outlet temperature is higher than the feed water inlet temperature. So this mass flow rate of water is given in the question in kilogram per second. So I will write first here the unit. So it is given in kilogram per second. Then the specific heat. So here specific heat of water is not mentioned, but we should know that that is the specific heat of water is 4.2 kilojoule per kilogram degree Celsius. And this temperature difference. So if we observe this inlet feed water temperature is given in degree Celsius. So outlet feed water temperature we have to find out in degree Celsius only. So here it is in degree Celsius. Now if we observe, this kilogram is getting cancelled, this degree Celsius is also getting cancelled. And what is this Q? That is Q is kilojoule per second. So this is the unit. So we have to take the into considerations what are the units that is given, and according to unit we have to convert all the data that we have to find out. Now next is mg, that is the mass flow rate of gas. So it is also given in kilogram per second. Cpg, that is the specific heat of flue gas. So it is given in kilojoule per kilogram degree Celsius, and here is the temperature difference. So if we observe here, outlet temperature is given in degree Celsius. Now we will first solve this. So if we observe what is the mass flow rate of water, so it is 600. Then specific heat of water, so it is not given, and it is equal to 4.2 kilojoule per kilogram degree Celsius. So we will write here 4.2. Now outlet temperature of feed water. So what is the condition for outlet temperature? It is the saturated water and pressure is 140 bar. So whenever the saturated water is given, then we can use here this steam table. So in steam table, here the heading is given, that is the saturated water and steam pressure table. So in the bracket it is given that pressure table. Because we are referring this pressure, so we have to refer this pressure table for saturated water and steam. So condition is saturated water and pressure is given. So we will find out what is the temperature for 140 bar. So here in this pressure we will find out where is the value of 140. So at 140 it is 336.6. So after P there is the notation T, and that is temperature. So we will use here directly the value 336.6 minus inlet feed water temperature, that is 170 degrees Celsius. So it is given. So which is equal to, now mg, so it is also given mass flow rate of this gas. So it is 1250. Then Cpg, that is the specific heat of gas, it is also given 1.12. Tgi minus Tgo. So if we observe here, the inlet flue gas temperature is not given, but outlet is given. Now if we observe, when flue gas is entering into this duct, then here is the higher temperature. So we have to take first inlet flue gas temperature minus outlet flue gas temperature, that is 450. Now we will solve this and we will find out this Tgi. So how to solve this? So with the help of calculator we will find out all these values and we will find out this value of Tgi. Now we will understand how to find out log mean temperature difference with the help of diagram. Now if we observe, here is the total length of the tube. Now we will plot the temperature of the flue gas as well as temperature of the feed water. So what is the temperature of flue gas? That is inlet temperature is 750 degrees Celsius. So I will plot here as a Tgi because of temperature of inlet flue gas, Tgi. Here 750 degrees Celsius. And what is the temperature of outlet flue gas? That is Tgo, 450 degrees Celsius. So I will plot here outlet, that is Tgo. I will show here with the help of arrow. So here the heat is given to the feed water and its temperature is getting decreased. So we have to show arrow from inlet to outlet of the flue gas. Now we will move for the next. Here feed water. So feed water is moving in the opposite direction of the flue gas, that is from the downward direction to the upward direction. And what is the temperature of feed water? That is 170 degrees Celsius. So I will plot here, that is the inlet feed water temperature, TWI. And what is the outlet feed water temperature? That is 336.6 degrees Celsius. So here I will plot TWO. So I will show this. So feed water is moving, that is from inlet to the outlet, and arrow is here. As the heat is getting absorbed from the flue gas, its temperature is getting increased. Now how to calculate the log mean temperature difference? So log mean temperature difference for the counter flow is given by the formula theta I minus theta O divided by log to the base E theta I by theta O. So what is this theta I and theta O? So I will show here, that is theta I and theta O. So it is very simple to understand with diagram. So this is nothing but theta I. And where is theta O? So here is the theta O. Now how to calculate theta I and theta O? So first I will take theta I. And here I will take theta O. Now with the help of diagram only we will make the calculations. So TGI. So TGI is 750 and TWO. So TWO is 336. So 750 minus 336.6. It is 413.4. So we have to get 413.4 degrees Celsius. 413.4. Now we will calculate theta O. So for theta O, it is the difference in between outlet flue gas temperature and inlet feed water temperature. That is 450 minus 170. 450 minus 170. That is 280 degree. 280 degrees Celsius. So here is also degrees Celsius. Now we will put here the values. So if we observe, we have to take LMTD cross, that is LMTD actual is equal to LMTD counter. So this theta I theta O, or this formula is for LMTD counter, and this is the correction factor. Now I will put the value theta I 413.4 minus 280 divided by log to the base E 413.4 divided by 280 multiplied by 1.12. So we have to solve this. So log to the base E, how to solve? So first we have to take, here is the log sign in the calculator. So log in the bracket we have to take 413.4 413.4 divided by 280. Bracket complete. So don't forget to take the bracket. So when we calculate this, it will become 0.16, that is 0.169. So it's a denominator 0.169. Now we will calculate all this. So calculated value of log mean temperature difference, that is for counter flow it is 789.34 degrees Celsius, and log mean temperature difference cross with correction factor it is 884.07 degrees Celsius. Now we will calculate what is the total surface area of these coils. So if we observe, these are the coils. So what is the total surface area? So how to calculate? So here if we observe the first formula, that is the heat transfer between this feed water and flue gas, that we have shown with the formula, that is notation Q. So here we will use the same formula, that is MWCPW in the bracket TWO minus TWI, that is the mass flow rate of water, specific heat of water, and the temperature difference of feed water from the outlet and inlet, which is equal to overall heat transfer coefficient into surface area. So here this is the total surface area of the coils multiplied by log mean temperature difference for the counter flow. Now here if we observe, this value of overall heat transfer coefficient is given in watt, and we have calculated this value in kilojoule per second. Now how we can decide the unit? So here this 600, that is mass flow rate, is given in kilogram per second. Then specific heat is given kilojoule per kilogram degree Celsius, and this temperature difference is in degree Celsius. So this kilogram is getting cancelled, this degree Celsius is getting cancelled. So what is the unit? Kilojoule per second. Now we know that joule per second, that is watt, so it is equal to kilowatt. But here this overall heat transfer coefficient is given in watt, so we have to also consider this in watt. So we will multiply here with 10 raised to 3. So with 10 raised to 3, which is equal to this 80 watt multiplied by AS into LMTD counter. So this counter flow here 789.34. So what is this surface area? That is 6624.5 meter square. Now we will calculate what is the number N, that is the number of coils. So number of coils, that is ms. So we will take the mass flow rate of steam. So mass flow rate of steam, if we observe here, this feed water is entering into this pipe and it is moving inside these coils. So how we can define this ms? So we will define this pi by 4 di square into Vw by Vfw multiplied by number of coils, which is equal to, now this value of mass flow rate of feed water is given, that is 600. So we have to take this 600. Now what is this di? That is the inlet diameter of these tubes. So inlet diameter is given in millimeters, so 60 by 1000 square. So pi by 4 we will keep as it is. Now here is Vw and Vfw. Now Vw, that is the velocity of water, and it is given, that is 1.2 meter per second. Now what is Vfw? So this Vfw we have to use for this saturated water. So for this saturated water, again we will use the steam table. So how we can define this Vfw? So what is the given condition? So given condition, that is 140 bar. So again we will use the pressure table, and for 140 bar, here what is the value of Vfw? That is Vf is given 0.00161. So here it is given for the 140 bar. So we have to refer the pressure table, because here for given condition saturated water is there and pressure is 140 bar multiplied by N. So all the values are known, so we can calculate this unknown value, that is N, that is equal to 285. So these are the number of coils. Now when we calculate this, we will move to calculate the L, that is the length of the tube. So how to calculate its length? So for that we have one formula, that is AS is equal to, so AS, that is the total surface area of these tubes, which is equal to pi DOL. So what is this pi DOL? That is this total perimeter, that is pi multiplied by DO. DO, that means outside diameter, and multiplied the total length. So this total length and multiplied by the number of coils. So number of coils we have calculated, that is 285. So we have to put the value here. So AS is also getting calculated, 6624, which is equal to pi into DO, outside diameter we have to take into meter, into L into 285. So L is equal to 105.68 meter. So now this value is getting calculated. Now we will calculate the number of turns. So for this number of turns we have formula L divided by B minus 2C. So what is this B? That is this width, and it is given, what is C? That is clearance. So clearance multiplied by 2. So when we put all the value, that is 105.68 divided by 4.68 minus, now C clearance is given in millimeter. So we have to convert it into meter and multiply with 2, that is 0.1. Then we will get capital N is equal to 23. Now what is the question? Question is that we have to find out the vertical height. So height is equal to pitch multiplied by this number of turns. 23 multiplied by pitch, we have to convert it into meter. It is given in centimeter, 0.08, which is equal to 1.84 meter, and this is the answer.